Welcome to Balaya Math Lectures. Learn every step. Today we will discuss the eigenvalues and eigenvectors of square matrices. Let me start with the definition. Let capital A be a square matrix and capital X be a non-zero vector such that Ax is equal to lambda x, where lambda is a scalar. Let capital A be a square matrix and capital X be a non-zero vector such that Ax is equal to lambda x, where lambda is a scalar. Then you can say that your lambda is eigenvalue and x is eigenvector. Here lambda is also called characteristic value, proper value, latent value or eigenvalue. All the names are same for lambda. In the similar fashion, x is also known as characteristic vector, eigenvector, latent vector and proper vector. If Ax is equal to lambda x, take this lambda x to left hand side, then this becomes A minus lambda I into x equal to 0. This is homogeneous system of equations. Let me remind one thing. If Ax equal to 0 is a homogeneous system, if det A is equal to 0, then the system has non-trivial solution. If det A is equal to 0, then the system has non-trivial solution. If det A not equal to 0, then the system has trivial solution. This is already explained in your homogeneous system of equations. What is a trivial solution? Which is zero solution. Non-trivial solution means non-zero solution. If det A is equal to 0, then the system has non-zero solution. What is here? What I have mentioned about x here? X is a non-zero vector. A minus lambda I into x equal to 0 is homogeneous system and x is non-zero vector. Then what will happen? That A minus lambda is equal to 0. That A minus lambda I equal to 0 is called characteristic equation. That A minus lambda is equal to 0 is called characteristic equation. On solving this equation, you will have the roots eigenvalues. The values of lambda are known as eigenvalues. And you can find the eigenvectors from this equation by writing as A minus lambda into x equal to 0. While solving the problem, you can get more clarification. Give me one example here. Square matrix 5, 4, 1, 2. And I am choosing 1 minus 1 as a vector. Then you can get something into 1 minus 1. What is that something? That means Ax is equal to lambda x. Here I am taking A and x. It is also x. You need to find lambda here. How can I choose this x? Is also a different question which will be solved from this equation. Ax is equal to lambda x and A minus lambda is equal to 0. But I know the values previously, that's why I am giving the values directly. Okay, right. If you multiply these two matrices, 5 minus 4, which is 1, 1 minus 2, which is minus 1, that means your lambda value is 1. Here, your x 1 minus 1 is eigenvector and the value lambda is equal to 1 is eigenvalue. And you can see one more eigenvalue and eigenvector for the same matrix, which are 5, 4, 1, 2 into 4, 1 is equal to something into 4, 1. What is that something? You can find it from this one. That means 5 4s are 20 plus 4, 24. 24, how can you get it? By multiplying with 6. 6 4s are 24. And also 4 plus 2, 6. 6 into 1 is 6. That means your eigenvector is 4, 1 and eigenvalue is 6. That means this matrix have two eigenvalues 1 and 6 and the corresponding eigenvectors are 1 minus 1 and 4, 1. Let us solve some problems, then you can get more clarification on finding of eigenvalues and eigenvectors of matrices. Let us see one problem on finding eigenvalues and eigenvectors of matrices. Here I am going to give 3 problems which were repeated in the examination so many times. Here it is the problem. Find the eigenvalues and eigenvectors of the matrix 8 minus 6 2, minus 6 7 minus 4, 2 minus 4 3. We know the procedure that we need to write the characteristic equation and then after finding the eigenvalues, and you can find the eigenvectors corresponding to the eigenvalues. The characteristic equation of A is that A minus lambda I is equal to 0. That means you have to subtract lambda from the diagonal and find the determinant of that matrix. That means determinant of 8 minus lambda minus 6, 2, minus 6, 7 minus lambda minus 4, 2 minus 4, 3 minus lambda equal to 0. Let us expand the determinant. 8 minus lambda into, I am multiplying directly, which is 7 3s are 21, minus 7 lambda minus 3 lambda minus 10 lambda, minus lambda into minus lambda, lambda square plus lambda square, minus 4 4s are 16, minus into minus plus, but AD minus BC, so that minus 16, plus 6 into minus into minus plus 6 into, remove this column and this row, minus 6 into 3 minus lambda, that means 6 lambda minus 18 plus 8 plus 2 into, remove this row and column, 6 4s are 24, minus 2 into 7 minus lambda, 2 7s are 14, minus 14 plus 2 lambda equal to 0. Now let us simplify, that is 8 minus lambda into lambda square minus 10 lambda 21 minus 16 plus 5 plus 6 into 6 lambda minus 18 plus 8 minus 10 plus 2 into 24 minus 14 10 plus 2 lambda equal to 0. That implies multiply with the constant to all the terms. So 8 lambda square minus 80 lambda plus 40 minus lambda cube plus 10 lambda square minus 5 lambda plus 36 lambda minus 60 plus 20 plus 4 lambda equal to 0. Let us simplify with higher powers. That implies minus lambda cube, and how many lambda squares are there? 8 lambda square, 10 lambda square, 18 lambda square plus 18 lambda square, and coming to lambdas, minus 85 lambda plus 40 lambda, which is minus 45 lambda, minus 45 lambda, and constants, this is a plus 40, 20, 40, 20, 60, minus 60 cancelled out. So it is becomes 0. I am taken out lambda as common and multiply with minus also. Then this becomes lambda into, so lambda square minus 18 lambda plus 45 equal to 0. So lambda equal to 0, and you can split into factors as 3 15s are 45, 15 plus 3 is 18. That means, that implies lambda into lambda minus 3 into lambda minus 15 equal to 0. So the values of lambda are 0, 3, 15. Therefore, the eigenvalues are 0, 3 and 15. Now, let us find the eigenvector corresponding to each eigenvalue. Yeah, let us find the eigenvector corresponding to the eigenvalue lambda is equal to 0. Let x1 is equal to x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda is equal to 0. Let x1 is equal to x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda is equal to 0. That is ax equal to lambda x. So that means as lambda is 0, simply ax is equal to 0. That means this matrix into x1, x2, x3 equal to 0. That 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4, 3 into x1, x2, x3 equal to 0, 0, 0. Which is homogeneous system. Let us reduce this one into echelon form. How? That implies R2 tends to 8 into R2 plus 6 into R1, and R3 tends to 4 into R3 minus R1. Then this becomes 8 minus 6 2. This is 0, And 8 7s are 56 minus 36, 20. 8 4s are minus 32 plus 12, which is minus 20. 8 minus 8, 0. Minus 16 plus 6, minus 10. 12 minus 2, which is plus 10. Into x1, x2, x3 equal to 0, 0, 0. Now, use this element and make this one as 0. That means R3 tends to R2 R3 plus R2. 8 minus 6, 2. 0, 20 minus 20, 0, 0, 0. Into x1, x2, x3 equal to 0, 0, 0. Which is in echelon form. So, rank less than number of unknowns. The rank is 2 as the number of non-zero rows are 2. Therefore, rank of A is equal to 2 less than 3, which are the number of unknowns. That means the system has infinitely many solutions. The system has infinitely many solutions. And n minus r, which is 3 minus 2 equal to 1 linearly independent solution. Let us find the solution. That means by writing the equations. So 4x1 minus 3x2 plus x3 equal to 0. So x2 minus x3 equal to 0. As there is one linearly independent solution, you need to take one variable as constant. So let x3 is equal to k. That implies x2 is also k by taking this one to that side. By substituting these values in this one, this becomes 4x1 is equal to 3x2 minus x3. That is equal to 3k minus k, which is 2k. So your x1 is 1 by 2 into k. So the eigenvector corresponding to the eigenvalue lambda is equal to 0 is x1 is equal to something into k. That something is nothing but 1 by 2, 1, 1. And if you multiply with 2, then this becomes 1, 2, 2 is the eigenvector corresponding to the eigenvalue lambda is equal to 0. Now let us find the eigenvector corresponding to the eigenvalue lambda is equal to 3. Let x2 is equal to x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda is equal to 3. That is ax equal to lambda x. That means a minus lambda I into x equal to 0. That implies a minus lambda I into x equal to 0. You have to subtract this lambda from the diagonal of the matrix A, which is 3. If you subtract 3 from this one, then this becomes 5 minus 6, 2 minus 6, 4 minus 4, 2 minus 4, 0 into x1, x2, x3 equal to 0, 0, 0. Now we have to reduce this one into echelon form again. That means R2 tends to 5R2 plus 6R1 and R3 tends to 5R3 minus 2R1. If you do so, then this becomes 5 minus 6, 2 and it is 0 as 5 6 are minus 30, 6 5 are plus 30, minus 30 plus 30 becomes 0. 5 4s are 20 minus 36, which is minus 16, minus 20 plus 12 minus 8. This becomes 0 and minus 20 plus 12 minus 8. 0 minus 4, which is minus 4 into x1, x2, x3 equal to 0, 0, 0. Now use this element to make this one as 0. R3 tends to 2R3 minus R2. Then 5 minus 6, 2, 0 minus 16 minus 8 and this row becomes 0 into x1, x2, x3 equal to 0, 0, which is in echelon form again. So the rank of the matrix is 2 and the number of unknowns are 3. Therefore, rank of A is equal to 2 less than 3 is equal to n. That means the system has infinitely many solutions and n minus r, which is 3 minus 2, one linearly independent solution. So that 5x1 minus 6x2 plus 2x3 equal to 0. And if you divide this one with minus 8, 2x2 plus x3 equal to 0. And also you need to take one variable as constant. Let x3 is equal to k. That implies x2 is equal to minus k by 2. Let us substitute these values in this equation. Then this becomes 5x1 is equal to 6x2 minus 2x3. So which is 6 into x2 minus k by 2 minus 2 into x3 2k, which is 3 times minus 3k minus 2k minus 5k. But you need x1, therefore x1 becomes minus k. Therefore the eigenvector corresponding to the eigenvalue lambda is equal to 3 is x2 is equal to something into k, that something is x1 minus 1 in x2 minus 1 by 2 and in x3 it is 1. If you multiply this one with 2, minus 2 minus 1, 2 will become the eigenvector corresponding to the eigenvalue lambda is equal to 3. Now let us find the eigenvector corresponding to the eigenvalue lambda is equal to 15. Let x3 is equal to x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda is equal to 15. That is x is equal to lambda x, which is a minus lambda into x equal to 0. So let us subtract lambda is equal to 15 from the diagonal of the matrix A. Then this becomes 8 minus 15 minus 7 minus 6 2 minus 6 7 minus 15 minus 8 minus 4 2 minus 4 3 minus 15 minus 12 x1 x2 x3 equal to 0 0 0. Use this element to make these two elements as 0. That means R2 tends to 7R2 minus 6R1 and R3 tends to 7R3 plus 2R1. Then this becomes no change in the first row, minus 6 minus 7 minus 6 2. So 7 6 are minus 42, 6 7 are plus 42. Minus 2 minus becomes plus. So this becomes 0 minus 56 plus 36, which is minus 20. And minus 28 minus 12 minus 40. And this becomes 0 minus 28 minus 12 minus 40, 7 12s are minus 84 plus 4 minus 80 into x1 x2 x3 equal to 0 0 0. Now use this element to make this one as 0. That means R3 tends to R3 minus 2R2. Then this becomes minus 7 minus 6 2 0 minus 20 minus 40 and 0 0 0 into x1 x2 x3 is equal to 0 0 0. So which is an echelon form again? The rank of the matrix is rank is 2 and the number of unknowns are 3, which is less than the number of unknowns. So that means the system has infinitely many solutions and has n minus r linearly independent solutions. So let us write the equations to find the solution. That means minus 7x1 minus 6x2 plus 2x3 equal to 0. And dividing with minus 20, then this becomes x2 plus 2x3 equal to 0. As there is one linearly independent solution, you need to take one variable as constant. So let x3 is equal to k. Let x3 is equal to k. That implies x2 is minus 2k. Substitute these values in this one. Then this becomes minus 7 into x1 is equal to 6x2 minus 2x3. 6 into minus 2 minus 12k minus 2k, which are minus 14k. That implies x1 is 2k. Now the eigenvector corresponding to the eigenvalue lambda is equal to 15 is x3 is equal to something into k. That something is x1 2, x2 minus 2 and x3 is 1. So 2 minus 2 1 is the eigenvector corresponding to the eigenvalue lambda is equal to 15. This is the way how to find the eigenvalues and eigenvectors of a square matrix. And I request you all, please like, share, comment and subscribe my channel Balaya Math Lectures, learn every step.